Welcome to the third episode of the Space Infrastructure Hub podcast series. I'm Daphne Molewa from SASTA, the South African Agency for Science and Technology Advancement, which is the business unit of the National Research Foundation. Today, I'm joined by Dr Gxokwe from SANSA, the South African National Space Agency. And today he will be unpacking a theme on agriculture and Earth observation. Sia, please introduce yourself.
Hi.
Just tell us a bit about your work and how you got where you are today.
Thank you, Daphne, and thank you for welcoming me to your podcast. My name is Siyamthanda Gxokwe, but I prefer being called Sia. I work as a remote sensing scientist at the South African National Space Agency with interest that lies more onto the applications of remote sensing in agriculture and a little bit of biodiversity. And I have a PhD in environmental and water science from the University of the Western Cape, which looked more into the use of remote sensing, or which developed a framework that was used to detect and monitor small seasonal flooded wetland systems in South Africa. I also hold a master's degree in hydrogeology, which is the science of groundwater, with a cum laude from the University of the Western Cape as well. Prior to joining the South African National Space Agency, I was working for the South African National Biodiversity Institute, where I was working as a postdoc there for 1 year, 7 months, which my work was more onto the data science, geospatial data science sorting, and also looking into developing frameworks for detecting and improving the monitoring of wetland systems in South Africa under the unit called the Water and Freshwater Group. Yeah, and then before that, I was also a lecturer at the Cape Peninsula University of Technology, where I was teaching more hydrogeology and hydrology, as well as the spatial science for water resources monitoring. Yeah, until October 2024, where I joined the South African National Space Agency as a remote sensing scientist, where I was recruited to work as a remote sensing scientist, which focuses more on the applications of remote sensing onto the agricultural assessment and monitoring in South Africa, from your croplands to your rangelands, amongst other. Thank you so much.
Oh, Sia, you have such a vast, I would call it a science CV. What really sparked your interest? How did it all start? What sparked your interest in remote sensing?
Actually, I didn't have an interest in remote sensing. When I started going to university, or when I matriculated in 2009, I then went to look for admission. And then when I applied at the University of the Western Cape to study nursing, I'm going to tell you a little bit of how did I end up being at doing environmental and water science. So when I got there, they told me that, okay, I met the requirements. I even exceeded the requirements for me being admitted to the course that I initially applied for, which was nursing. But when I got there, they told me that there is not enough space. You know, there's always health degrees are very competitive. So when I got there, they said that you could have came yesterday. It was that time where they didn't have actually access to our metric results as they being released. So you were required to at least got your statement, and then you go to the university to submit the actual results before you can get your final acceptance. So when I went there, they told me that, no, we don't have enough space. We've recruited, the course is full oversubscribed, so we cannot take any other person. So you have to go and find something else. And then, so I was like, okay, what is it now? What should happen now? Because I did apply as early as possible for this course, and I met the requirements. And then they said, okay, we've got some courses that are available in the science faculty. So then I went there. When I got there, they told me that we can put you in environmental and water science. I didn't know what it was about. So I was like, okay, because I didn't want to stay at home, like to spend 1 year without studying. So I needed to do something. I had initially had plans of saying that I'll probably switch to a health related career when I get the admission to the university, which didn't happen because I started falling in love with the course. So I registered and then I started being involved in so many related activities that are under the course. So things that like your field work amongst other things. So I became more interested into the GIS and remote sensing stream, which is where now the love of remote sensing initially started. And then I continued from undergrad honors. And then when I get to master's, then I was recruited under a Water Research Commission bursary to work on a water-sensitive urban design project, which was more onto the hydrogeology. So I did that master's under hydrogeology, which is groundwater science. And then I'm not going to go much on what I focused on, but I did that, and then I managed to get a cum laude and get a couple of papers published out of that work. And then after that, I then decided that no, my first love was actually remote sensing under this course. So I probably need to consider doing something relating to remote sensing again. So I was approached by this other professor who is the professor of geospatial sciences, Professor Timothy Dube at the University of the Western Cape. He then said that there was a project on wetlands, a remote sensing of wetlands. And that time he was still new at that department. So he didn't have any students, and then he recruited me, and then I was like, okay, I have interest in pursuing a PhD on that topic. And then that is where now I became exposed to so many remote sensing applications amongst other things. And then I was sort of like more comfortable. Then I became happy. Then I started following my passion, which was the remote sensing stream within environmental and water sciences.
No. So let's unpack it. What is remote sensing? What does a remote sensing scientist do on a day-to-day basis?
So, in layman's term, basically, remote sensing is understanding an object without going into physical contact with it. So, for most of the environmental work that we do requires one to be able to go out to the field to be able to understand the patterns and changes of whatever phenomenon that they're looking into. So with remote sensing, you rely more onto the satellite data, which allows you to be able to understand certain environmental changes without being out there in the field, being physical contact there. For example, what we are doing as a day-to-day remote sensing scientist at the South African National Space Agency, we take the satellite imagery, or which are the images that are collected by the satellites in the outer space. We then subject those images into models for us to be able to predict what is going on our environment. For example, where we are monitoring the agricultural practices in South Africa, water resources, amongst other things, without having to go out into the field to actually look at some of these patterns and changes that you would observe. On and on, we are interpreting what the satellite is actually giving us for us to be able to look and understand what is going on in the environment so that we can be able to propose solutions if need be.
All right. And so how does your work then at SANSA assist ordinary South African? Are we able to look at droughts through, your work, or is it something more complicated than that?
Actually, what you've just said now is part of the work that we are doing at SANSA. So when we look, we do monitor climate change. Of course, we rely on surface indicators that are there that are actually telling us about a certain phenomenon. So what happens is that remote sensing or satellites are able to pick up those changes and would be able to interpret such changes for us to be able to understand what is going on in the environment. For example, drought can actually affect the planting and the crops that are out there. So now, for us as remote sensing scientists, we rely on the imagery to look whether the crops are actually compromised in terms of the quality and in terms of the health, amongst other things. And then that will give us insights on what is going on out in the field. And then we can then propose solutions to curb whatever that is being experienced in the environment.
All right. And are those findings, your findings, are they accessible to small-scale farmers or rural farmers in South Africa?
Certainly, yes, because we are working mostly with the small local municipalities. Those are also some of the clients which have direct one-on-one with the small-scale farmers that are out there in deep rural areas. So we then communicate the findings and outputs to them, and then we trust that they do communicate those findings with the people that are on the ground, like your small-scale local farmers that are out there. But now what we are trying to do also, we are also trying to cut down onto the middlemen to try and come up with these systems that a farmer can then be able to access that information onto their particular cell phone. If I can make an example now, we are sort of like trying to build a smart water use app that is actually going to go into a cell phone where a farmer can be able to access the crop water requirements and crop water use by that particular crop. So we are trying to sort of like cut that middleman so that the farmer can have direct access to the information, because we don't know how long it takes for the small municipalities to communicate such information to the farmers that are out there.
Okay. And also, so now, what are the biggest challenges that you find with remote sensing that are related to agriculture in South Africa?
One of the biggest challenges that we are facing with the remote sensing is basically the uptake of the remote sensing and convincing people to actually trust the remote sensing. People, tend to say that you cannot monitor what is going on onto the ground using something that is in the outer space. You are very far. They believe that you need to go there so that you can see such changes. So basically, ensuring that people uptake remote sensing is quite challenging. And now, with all these systems and engagements that we are having, we are also trying to go out to people and to show them that this is actually a tool that can work hand in hand with your field measurements, so that you can be able to gain a more robust understanding of what is going on out there. Because when you are focusing more on the traditional approaches, like going out into the field, there's some challenges, like your funding challenges. So what we are saying is that now we are proposing a solution that would work hand in hand with the field traditional measurements to more enhance the monitoring, meaning that now, instead of you monitoring that one small farm that is in a Diken, you can then look at more farms within the Inquba Yetemba municipality, rather than having just one person monitoring that. Meaning that at different time periods, and also at any given time, you can be able to access information at your office, rather than requiring to travel and download data, which is quite daunting and quite costly if you have to look at it. So we are going out trying to engage people to ensure that they uptake, or they understand that there is these technologies that are out there that are there not to replace the traditional approaches, but to enhance what the traditional approaches cannot do at a particular time.
All right. Then, as things stand, are we able to say a rural farmer who can't get you, who you can go to, are we able to say they can take their cell phone and download some of these apps that you're talking about, and then will that then be able to assist them into understanding a few things in their farms?
Yes, certainly. So with the rural farms, we understand that also there's some challenges with communications network, amongst other things. But what we are trying to do is we are sort of like trying to build these technologies so that they can be compatible with the current scenarios that we are facing with regards to network, amongst other challenges. So we are sort of like trying, because everyone is on their smartphone. So if you go out now, you'd find someone busy on their phone. Even the farmers, they live that life. So then we then look into how do we then leverage on that, such that then it can enhance all the practices that they do into their field. So the way in which we are designing these technologies, we are sort of like trying to build them in a way that You just go out if you are looking whether you need to irrigate and how much do you need to put in there for that crop to be there. You just go and take a picture, and then the app would then derive what is the current scenario or the situation in that crop that you are having there, whether it is compromised or not, whether you need to sort of like irrigate if there's a need for irrigation, or you put pesticides if the pests that are out there are actually threatening the yield that you are supposed to be getting out of that. So we sort of like, instead of looking the old traditional way of having to have these sensors that would monitor moisture that is there, if you have to monitor moisture, or if you have to take samples to the lab and all that. So what we are trying to do is we are trying to say that, can we then use these technologies to develop systems that would allow one to be able to go out into the field and to their field and take a picture, and then minimize onto that cost that is involved in terms of taking samples, if they need to analyze nutrients onto the soils, if they need to do all those things, which might also delay the process of the response onto that. How do we then use these technologies now to bring into one big system that would actually monitor all these things in at one go, just by taking a picture, which is what we are trying to build. We are also developing decision support tools for agriculture, which would look into different agricultural practices, from croplands to rangelands. In terms of rangelands, where we are saying that how much rangelands that are healthy, and can you then graze certain livestock there, and also looking at then what is the carrying capacity of that rangeland, and is it palatable for those animals that you'd be grazing there. So those are some of the things that we are trying to build from these Earth observations or remote sensing systems that we have at the South African National Space Agency.
Oh, that's quite interesting. Then now, Sia, for the learner, someone is at home, they've just now in their matric, they want to get into remote sensing. Where do we start?
Okay, if they are interested in doing remote sensing and geospatial science, because it's a STEM-related career, so one, you need to probably have studied mathematics and physics or STEM-related subjects at high school. And then you need to either gain admission to the University of Technology, and even a TVET college that is offering careers that are relating to the work that you do. If I can count, there are certain universities that are offering GIS and remote sensing. That course would allow you to be able to come in. You can also do environmental and water science like me, and then you'll be able to get into remote sensing science. Or else you can do geospatial science, you can do environmental science. There's quite a lot of courses that have this remote sensing packaged onto their curriculum, which then allows you, as you are moving further with your NQF levels, then you'd be able to decide whether you want to focus more on remote sensing or other aspect of the course, or to combine remote sensing with other aspects. Because for me, I felt like I don't need to necessarily do remote sensing all. I need to also combine remote sensing, because I view remote sensing as a tool or a system that allows us to be able to understand the environment better. So it needs to be packaged with something that is relating to the environment. So what I'm saying is, now to the youth out there, you can, as long as you are doing a STEM-related subjects at high school, then you probably need to go and look for courses where remote sensing is packaged into the curriculum. Then you can become a remote sensing scientist like myself.
Well, thanks, dear. I'm hoping a lot of the youth will be joining you soon at Sansari.
Yeah. We need more people so that we can take the science of remote sensing to the other levels, and to come up with new innovations, because we need new innovations in this country. So we need new innovations that are going to be solving the current problems that we have. We're not saying that we're not coming out with innovations now, but we believe that with the time goes by, we need to adapt with all the changes that are happening, and there's new technologies that are being brought to us every single day. So now, with the new people that are going to be coming in, they should be coming in with the ideas that SANSA would probably give the room for them to be able to bring it up further. Those innovations that are going to be helping the country to move forward with their agricultural practices.
Well, yeah. Well, thank you for joining us, and thank you for giving us an insight into remote sensing. And we hope that our viewers will enjoy it. And for our viewers, thank you for tuning in.